So here we are with our scatter plot of this data, and just in summary, I got a regression line or a trend line in the Excel program. They call this a trend line. But it's a least squares regression line. And again, the R value, the square root of 0.8855 is 0.94. So we have this. I pulled this from the text. We have a bunch of different scatter plots here of data, and with their corresponding R values, so you can kind of get an idea what the R values mean. So if you look down here in the second row, all this data falls on a nice line, and every single one of these, even though they have different slopes, this one is horizontal living, and these are negatively sloped, all have an R value of 1. That means it's a really close representation. There's a good correlation between the X and Y values, a one-to-one correlation, a solid correlation, a linear correlation, and so that's why these have an R value of 1. Notice the R value is negative when the slope is negative. Now, in general, if you look at scatter plots up here, as they get more spread out, then the R value gets lower. So this is 0.8 and this is 0.4. And again, it's tending towards a negative slope here. So this is negative 0.8, and this is tending towards a positive slope. So it's positive 0.8, to the point where there really isn't any linear relationship between X and Y. So I mean, if you look at these as if there is an axis here. Suppose there's the XY axis here. You'll see that a line does not really represent this data very well, and that's why it's 0. And to just really drive that point home, you look at the third row, and none of those are linear. Some of them have like some sort of organization to it, but not linear. And that's about all I want to talk about in that section. But since we have some more time, let's discuss a little bit about curve fitting nonlinear data. And if we jump back to Excel, I have some data here that's not linear. You can see this is data that represents the divorce percentage as a function of age. So age is the x-axis, and I don't have time to set this up very well, but let's say this is age, and this is your percent of divorce. I'll just put percent D. So this is percent of population divorced by age. Notice it looks very parabolic, or like a quadratic equation. Well, we can also do a trend line, fit a trend line to this. So I selected the data. Notice when I select the data, I left click on it, the information used to plot the data is boxed over here when I do that. So again, I'm just going to right click and add a trend line. And so by default, it has a linear trend line here. And as you can see, I'll throw the equation up for this and the R value. The R value is pretty low, 0.25. So that's going to be like a 0.05 R value. So R squared is 0.25, so it's going to be like 0.05 R value, right? Or 0.5 R value. It's going to be a 0.5 R value. If you take the square root of that, I'm trying to do that in my head. I should probably use a calculator just like you guys. But so not a good representation of a linear correlation between this data. Well, what's interesting is we don't have to only do a linear, as you can see over to the right when I click on this data and I add a trend line, that I have a number of different types of trend lines. I could try an exponential. That doesn't look good. Exponentials grow exponentially. No. Logarithm, that might look a little better. There's a bit of a hump in it. Nope, that's not it either. Power might actually work. Nope, didn't work. But here, polynomial. Let's do a polynomial. And since this looks like a parabola, we know that that's a second order or second rank polynomial. I could make this higher order. And that actually the higher order I make this polynomial, the better fit I'm going to get to this line because it has more wiggle room in between, more ability to make for this function to squiggle back and forth. But let's just stick with a second order polynomial here, and I'll throw up the equation for that. So this looks like a second order polynomial or parabola. So again, this is a very useful program, and I just wanted to show you another option, another way to use it. And I pasted this in the notes so you can review it. Okay.